So subnetting is the breaking down of a network into multiple networks. We see this in both IPv4 and IPv6, but in IPv6 it is easier compared to IPv4. The reason is in IPv4 you no need to, in IPv6 you no need to borrow bits. In IPv4 we borrow bits. In IPv6 you no need to borrow bits. In IPv6 you have plenty of bits available, so you can make use of some bits for breaking down the network called subnetting. For the sake of subnetting alone, in IPv6 we have 16 bits, whereas in IPv4 your total address size itself is only 32, in which you need to have network, also host. So subnetting in IPv4 is difficult than IPv6 subnetting. When we go to IPv6, we'll discuss about IPv6 subnetting. I want to stop it here about IPv6 subnetting. Let us talk about IPv4.
Okay.
Do you know any reason why we need subnetting?
Subnetting, yeah, the same thing. One physical network. I mean, one big network into small network. Small network. Breaking. Small networks.
See, it need not to be big or small. A network, one network you are taking and you are breaking into multiple network. Even it may be a small network, you can take it and you can break it. So I don't want to go with big and small words here. Subnetting is breaking down a network into multiple networks. Of course, when you break, it will become smaller. There is no doubt. Now, my question is, why do we need subnetting? Or why do you need to break down one network into multiple networks? Why? Why do you need to break down?
It is for the when there is a troubleshoot. It is easy way to do the troubleshoot.
Okay. I
And
can understand a bit what you are thinking. You see, when we have one large network, troubleshooting will be difficult. So we break down a large network into subnets so that if there is a trouble, the trouble will be only within a subnet. It won't impact the other subnets. A kind of answer. I'm not denying that. Any other reason why we need subnetting?
it's like a logical separation to block the communication in between one network to other network if required at all.
No. See, logical separation and all we can do in VLANs, layer 2. Why do I need layer 3? Necessary. Not necessary. That's why we have VLANs to provide logical separation. IP layer itself is logical only. IP layer itself is logical only. So we cannot say like that. Okay, the reason is simple. I want many networks. That's the reason.
Okay.
I don't want just one network. I want many networks. Why? Why subnetting? We come on, what is this? I don't know why. Okay. Why subnetting? We need many networks. We need many networks. We don't want just one big, large network in our organization. We need many networks because we have many departments. We got many departments. Many departments. Each department need one separate network.
Yeah.
In that way, it is logical separation. I want to
Yeah.
have different networks. See, we do have layer 2 separation. VLANs can provide the real logical separation between one department and another department. But we also want to give different networks to each department. So we need many networks. That is why we are going to do subnetting. What is the advantage?
It is easy. I mean,
You
network
already told me, correct.
separation. Yeah.
When you have multiple networks, easy to isolate the issues. So this is one advantage. There are many. Because you got different network for each department, because you got each department a separate network, you will have dedicated network ID, broadcast ID,
Multicast.
no, dedicated network ID, broadcast ID for each department. So if you want to
Yeah.
send a traffic to all in one department, if you want to send traffic to every member in sales department, you can use the broadcast ID of that network of sales. When you use the broadcast ID of sales department, it won't go to production department. So each
Yeah.
department has got a dedicated broadcast ID when you do subnetting. If no subnetting, then for the entire office, there will be only one broadcast ID. So you will not be able to talk to one particular network if you want. If you want to talk to everyone in sales, it is not possible when there is no subnetting. So subnetting is good. Subnetting helps to break down the networks. Not only that, that breaking down of network provides control over the topology, control over the traffic flow, meaning when there is a flooding, when there is a broadcast, the broadcast will be local to a department, local to one subnet. So flooding, there's another advantage. Flooding will be localized
Yeah. Within the network.
within the department or network, within the
Network.
subnet. So because you are reducing the flooding of packet within a department, within a subnet, other departments are not going to unnecessarily get disturbed. They are not going to waste their bandwidth because the flooding is not reaching them.
Yeah.
So in another word, what I can say is subnetting improves bandwidth. How subnetting improves bandwidth? As I said, if you don't have subnetting, every single every single broadcast will go to everyone, all department members, wasting their bandwidth, their CPU. But when you do
Yeah.
subnetting, You localize the flooding. As a result, the broadcast of other departments are not wasted. In that way, we are improving the bandwidth. Improves bandwidth. Flooding of packet will be localized within the subnet. Improves bandwidth.
Yeah.
You see, likewise, we have few more advantage. We'll talk about that as we go further. Now, when we take enterprises, sometime it may be a small enterprises. You may need like just 5 departments. Some companies are large. They may need 50 departments, 100 departments. Depends on the organization. So we will not be able to predict how many they want and just go with one model. We need to know how to do subnetting if I need 10 subnets. How to do subnetting if I need 100 subnets. So that
Yeah.
knowledge is what we are trying to acquire now. Before that,
Yeah.
we need to know that every network has got a broadcast ID and subnet mask. For example,
Yeah.
when I say 10.0.0.1, and if I don't mention subnet mask, what is the meaning? The meaning is this belong to
By default /8.
correct class A. Because it
Yeah.
is class A, it means that, as you said, the default mask is, you can also write, as you said, /8. And now, if this is the network, if actually this is not a network, that's an IP.
Yeah.
That's not an IP, that's the first IP. If this is the first IP, and what will be the network? It is, this is the network. So what do I understand from this? I understand that I got 8-bit 4 pairs, which is 32-bit in total. In 32-bit, only the first 8-bit is network. That's the meaning.
Network.
The 255,
Yeah.
it means that all 8-bit are given for networking. See, to write 10, you don't need 8-bit. To write 10, what is needed? To write 10, it is 8 plus 2 plus, that's it. This is 10. This is 10. But this is what masked. The meaning of 255 is this. It means that these zeros should never turn to 1, and these ones
Yeah.
should never turn to 0. These zeros should never turn to 1. They are constant. That is the meaning of subnet mask. Subnet mask tells how many bits are given for network. And then this number tells that these are zeros and only 2 bits are 1. So this is one network, 10 network. Now, when
Yeah.
you do subnetting, when we do subnetting, we are breaking the rules. We are giving more than 8-bit for networking. When you do when you do subnetting using 10 network, with this 8-bit that is not possible because 8-bit is already been taken for network. So when you say subnetting, you actually what we do is we borrow some bits. We borrow some bits from where? From this bits which are not masked. They are not masked. They are meant for host. For the network only 8-bit is masked. For the network only 8-bit is masked. The other 24-bit, is given for host, but now you're going to take some bit and give it to network. If you take some bit and give it to network from this octet, then you will have some number here. In short, what I'm trying to say is, when you do subnetting, the mask will not be the default mask. Need to be very, 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 very important. The mask will not be default mask. The mask is going to be more than what is default. The default is /8. If I do subnetting using 10 network, definitely it will be /11 or /16 or /24. It depends on how many departments in a organization, or it depends on how many computers in a department, which we are going to see in detail in our next class with the board and pen. Now we are going to manage with what we have, so no writings now much. 10 network is class A, and this is what called as first IP, because the very first bit from the right, is on. So this is the first IP. The first IP. And the mask is 255.0.0.0 or /8.
Yeah.
Now what will be the last IP? When you make when we make all the host bits on, it will be seen like this: 10 dot, all 8 bits on 255, another all 8 bit on 255, another 8 bit on 255. So this is what we call it as broadcast IP. This is
broadcast IP.
Broadcast IP. Now, if this is broadcast IP, this should not be assigned to any computer. This is the broadcast IP for every computer whose IP address begins with 10. In your organization, 10. If you have computers starting with 10, to talk to all the computers that starts with 10, we will use this IP address. This IP address cannot be assigned to an individual computer because it's a broadcast address. Broadcast is to talk to everyone. Then what is the last IP? Last IP is 1 bit less than this. 1 bit less than this will be what? 10.255.255.254. This is one last. So what do you call it as? Last IP. This is last IP. So for any network you take, there will be first IP, there will be last IP, and there will be a broadcast. When you do subnetting, for each subnet there will be a first IP, last IP, and broadcast IP. For example, I'm not going to do subnetting, I'm not going to teach in depth subnetting now without pen and board, but I'm going to just write an example. For example, if I will borrow 3 bits, my subnet will be like this: 10.0.0.0, and the subnet mask will be 255. 224.0.0 because I borrowed 3 bit. It will be 255 in the second octet. And then the first IP will be 10.0.0.1. There is no change, same like what is above. That's the first IP. And then the broadcast IP will be like this: 10 dot 224 dot 10 dot. We have borrowed 3 bits. Okay, 10 dot 60 32 dot 0 dot 10 dot 31 dot 255 dot 255. This will be the broadcast, and the last address will be 10 dot 31 dot 255 dot 254. So we can see here the subnet mask is different. We don't subnet mask. And the first IP. And then last IP. And then broadcast IP. So this broadcast ID is only for those computers within this range.
Yeah. Sir, how your mask is coming actually? 255.224?
I have borrowed 3 bits from here. If I borrow 3 bits, I'll get 224. I'll show you how. You see, okay. Now, in this place, if you have 1, there is a value. There is a value here. There is a value here. And I said only 3 bits I borrowed. All the rest of the bits are 0. All the rest are 0. You know, the value of the first 3 bits in an octet is 254. I'm going to show you how. It's a binary number, right? Binary.
Yeah.
Our number system that we are using here is binary. So when you have binary, here this place is 2 to the power of 0.
Okay.
If it is 2 to the power of 0, and if you have 1 there on the top, the value is 1. Here it is 2 to the power of 1, which is 2. And here it is 2 to the power of 2, which is 4. And here it will be just doubling, okay? 8. More in depth, I need a pen and paper to teach you this, but I'm just trying to manage with what I have now. And here it is going to be, if you double 16, then it is going to be 32. Isn't it?
Yeah.
And here 64, and here 128. Now, I told you first 3 bits are borrowed. If first 3 bits are borrowed, sorry for this, I have to make it very clear for you. Okay, now I cannot move this anyway. So assume that this is the last bit, 128. Now you see first 3 bit, 128 plus 64 plus 32. Add and see.
It is 224 only.
Meaning,
1
listen.
minute. Let me calculate.
You take calculator. Okay, take calculator. Yes.
128 plus 64 plus 30,
Yeah.
224.
You see, how did you get this 255? Because all 8 bits are network, isn't it? When
Yeah.
all 8 bits are network, that's why you put /8. When all these bits are on, it is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which will be 255. You got it?
Yeah.
Now
Yeah.
I have not taken all 8 bit in the second octet. In the second octet, how many bits I told I have taken? Only 3 bit.
3 bits.
So
Yeah.
if I have only 3 bits taken, I'll just on only those 3 bits. When you on those 3 bits, only these values you need to add. You should not write 255 then. Only if you give all 8
Yeah.
bits, then it will be 255.
255.
I've just given 3 bits. So I write 224, which is 128 plus 64 plus 32. More in depth, we will be
32.
seeing that in our next class. Here, what I'm trying to say here, the subnet mask, you need to write it very correctly. Otherwise, even after subnetting, it will be equal to no subnetting. If you don't write proper
Yeah.
subnet mask, the device will not know how many bits are considered as a network. For example, the next network, the next network in the same subnet, when you borrow 3 bits, the next network will be 10.32.0.0. The mask is same, 255.224.0.0. And then the first IP will be 10.32.0.1. And the last IP will be 10.61. 164. Okay, 10.63.255.254. I'll teach you how I got 63 here. Right? Even in the previous thing, I have made a mistake. This is not 32, it should be 31. It's 31. In the broadcast, I have put correctly, but in the last, I have put a mistake, 32. Okay, 10.63, and the broadcast will be 10.63.255.25. Is this clear? No, I know it's not clear because we have not done subnetting thoroughly, but what I'm trying to show here is, if I don't have this mask, are you with me? Your voice is gone. Are you there? Are you in mute? You see, if I don't write subnet mask, this 10.32 will not be seen as another network.
Yeah.
Because you got this subnet mask 255.254, the IP address, like, let me write here, 10.0.0.1 and 10.32.0.1. If I don't put subnet mask, what will everyone think? That everyone will think that these two are in same subnet. Not only everyone will think,
Same.
even the machines will
Yeah.
think that these guys have got 255000 as the mask. So even the devices will think that we are in same subnet. And there is no need
Yeah.
for a router between these two to communicate. But when I write the mask correctly, when I write the mask correctly, when I put the mask like 255.25224, then these two computers will know that we are not in same subnet. If we are not in same subnet, what is needed, you know? We need router to communicate. Without the help
Yeah.
of router, these two cannot communicate because these two are not in same network. To
Yeah.
communicate between the devices which are in same network, you need only switch or back-to-back connection with the wire. But different network,
Yeah.
even if it is subnetted network, they are subnetted. They are no more, even though they are same network, 10, it begins with 10, they are no more same network. Why? Because you have subnetted.
Different
They
subnet.
are as equal as two different network. This
Yeah.
is as equal as 10.20.0.0.1 and 10.0.0.1. They are totally not same network.
Yeah.
This is as equal as this. They are not same network. They are different networks. Fine. So when you do subnetting, what is very important is mask. And when you do subnetting, for each department, you will get a dedicated subnet mask. Sorry, dedicated broadcast IP. For example,
Sir, I have doubt
yes.
actually. See, the above network 10.0.0.1, you are putting like 255.224.0.0 in the downside.
Hmm,
And again 10.32.0.1. And again you're putting
hmm,
10.224.0.0.
hmm.
This looks like same
See,
subnet, right?
subnet mask is same, but see this portion. This portion is not same. This
Yeah, okay.
portion is 32 here.
Network, different network, yeah, okay.
If you see the 32, it is here. This bit is already borrowed now for
Yeah,
networking.
yeah,
Here 0, here 0, here 1. Only then I will get 32. But to get the 0, will there be 1 here?
uh-huh,
No. This will also be 0. Agree?
0.
Ah, they're not same network.
Yeah,
So to say that they are not same subnet, to say that they are different subnet, you need this mask. If you don't have this 224, then they both are same. Because you got this 224, you say this 3 octet matters. To get this 0 in the second
mm-hmm,
octet, even the borrowed bits are zeros. All the bits are 0. To get this 32,
okay,
the borrowed bits are not 0. The borrowed bits, if you want to get 32, it is 1 here. These two are
yeah,
zeros. So
0.
they are not same, isn't it? But the bit is different,
Yeah, yeah,
you know. So this clarity you will get only when I do with proper subnetting step by step in the whiteboard. We'll go there, you know. I'm just giving
okay,
you an introduction.
okay,
We got we got an understanding here that when you do subnetting, even this looks same, the mask is looking same, the networks are not same. Not only that, for each department you get a separate broadcast IP. If I want to talk to all the devices in department 2, then I should use this address to communicate. If I send any packet to 10.63.255.255, it's not 254, the last number should be 255.
255. Yeah.
If I send any packet to this address 255.255,
255. Yeah.
then the packet will go to every computer in this department 2. And it won't go to department 1. That is why we need subnetting. We are not unnecessarily sending all the packets to all departments. If I want to send something to all that are in department 2, I got a dedicated address. Earlier, before subnetting, you didn't have this dedicated address.
Yeah.
Before subnetting, there is no dedicated address. This was the only broadcast address we had. Which one? This 10.255.255.255. If you send any traffic to this address, it will go to everyone.
Yeah.
Department A1, Department 2, Department 5, everyone. So subnetting, as we discussed the above, it is isolating the issue by providing each department a dedicated range of IP address. See, for this department, the range is only between 10.0 to 10.31. For the second
Yeah.
department, range is between 10.32 to 10.63. So it helps to isolate the issues by providing the range of address for each department. Not only that, it provides a dedicated broadcast IP and a network ID. Not only that, when there is a flooding, see there are a lot of flooding. ARP will flood, DHCP will flood. Whenever there is a layer 2 flooding, the flooding will be only within the department. It won't impact the other department. As a result, it improves the bandwidth. Okay, so subnetting is good.
Yeah.
Subnetting is by borrowing bits. Borrowing from where? Borrowing from the host bits. Because you are borrowing,
Yeah.
the mask will be more than what is default for the network. Now, before we go deep into subnetting, which we are going to do in the next class, we need to know the ranges of class A, B, and C. Class A range is any address that begins with 1 to 126 is class A.
Yeah.
In class A, the first octet is network, the first octet is network, and the other two octets are host. Host. So the other three octets. So how many host bits you got? In class A, how many host bits we got? Are you there? Or are we disconnected?
Yeah. Yeah. I'm here,
Okay.
sir.
How many host bits? See, there are totally 32 bits. Only 8 bit is network.
Yeah. 8 bit network.
So how many host bits we got?
24.
Yeah, 24.
24.
I know it is very basic. You know these things. Just to refresh
No, sir.
one time.
Yeah, consider me that I don't know, sir, because I also want to
Okay,
review each and
no
everything.
problem.
Yeah.
That's good. Now for class B, if you take
128 to
class B
or 1
ranges,
20.
you're right, 120. It's not 127. It's
Yeah,
128 to
229, I think.
191. And then
Okay. Yeah.
this second octet is also network.
Okay. Not coming.
Uh-huh. It is
Yeah,
like
now
that.
it. Oh, yeah, yeah. Yeah.
So second octet is also network. Whereas for class C,
Third octet will be.
the range is
228.
192
223.
to
Okay.
223. Okay. So here also we have another 8 extra
Yeah.
bits for network. So more the network bit, less the host bits. So we got 3 octets of network in class C, which means 24-bit pointing to the network.
Oh,
Only 8-bit for
yeah.
naming the computer's host. Whereas in class C, class B, equal,
Host.
8 bits for network and
Yeah.
8 bits for host. 16
Yeah.
bit for network and 16 bit for host, equal. And in class A, only
No.
8 bit is for network and
No.
then
No.
24 bit is for the
24
host.
bits for
So, yeah, 8 bit for network,
class
24
C,
bit
sir.
for the host,
Are you talking?
isn't it?
Oh, class A. Okay. Fine.
Class
Yeah.
class class A, class A. Class
Okay.
A, only 8 bit for network,
Host. Yeah.
24 bit for the host. So this range is very important.
Yeah.
223, 191, 126. What happened to 127?
Reserve
127 beginning address, any address that begins with
used.
127 address
Yeah.
cannot be given for a computer. When you try giving, what will happen is it will say this has been
Hmm.
dedicated for loopback address. See, loopback address is not assigned by us. It is predefined by the standard. Say, for
Yeah.
example, I'll go to the command prompt now. Now I'll just
Yeah.
type the number that you will tell me. Okay? I'm saying ping 127.
Zero
Give
dot
me
zero dot
numbers,
one.
some number, 3 numbers.
Yeah.
0.0.1. Okay. See, I have not assigned
Computer.
this
Yeah.
address
Yeah.
to any of my
Yeah.
computer network
Yeah.
adapters, but I'll get reply. Now
127
again,
dot
give me another number.
0.0.10. Okay. 23. Yeah.
Why always 00? Let's say 23
Yeah.
dot another number,
10 dot 20, 23.
10 dot
Yeah. Yeah.
23. You see, again someone is replying me. Who is replying me? When did I assign
Yeah.
this address to my computer? I have never assigned. But any address that
No.
I put,
Yeah.
someone is replying me. See, it's a reply. See, whenever I put 127 and ping, operating system is replying. Who is replying? Operating system is replying. When will the operating system reply? Whenever you have all the drivers, network drivers properly installed. Whenever your laptop is ready to communicate to the network, internet, only then operating system will say, I am ready. This is the reply. What does it mean? It means that I am ready for connecting to the internet. You understand? I am ready. That is what the loopback address is. It's a self-diagnostic program. It's a self-diagnostic program that is running, diagnosing whether the computer is available for, ready for communication. Are you there? I'm not getting your voice. Are we disconnected? It means that your computer is ready to
Yeah.
communicate to anyone in the internet. It's ready.
Yeah.
It's ready. If you don't get a reply to 127, then you
Yeah.
need to check the network card,
Yeah.
and or you need to check the driver. If this is not properly installed,
Yeah.
you will not get reply. When you get reply, it means your computer is ready for communication,
Yeah.
ready to go, ready to use. All right, fine.
Yeah.
So
Sure.
we'll stop here. We'll continue